Okay, so think about your office for a sec. What's the one piece of tech you never, ever think about? Your keyboard? Maybe your monitor? Well, what if I told you it's actually that printer? The one just sitting over there in the corner? New research is showing that humble machine could be a massive, gaping security hole for your whole network. So really, is your printer a security risk? Yeah, it is. Today, we're going to dive into some absolutely groundbreaking research. It shows how one single, totally harmless-looking print job could be the exact key an attacker needs to just waltz in and unlock your entire system. Right, so to really get a handle on this new threat, we've got to look back at the old one first. See, printers have been an attractive target for hackers for a long, long time. They're often just forgotten. And this isn't some theory, It's a well-known, proven weak spot in network security. And the real danger here isn't an attacker kicking down the front door. Nope, it's more like they have a key and can just walk right in. They use completely legitimate, totally open pathways to send a malicious file that, to you and your printer, looks completely normal. That makes it an incredibly stealthy way to get inside. And look, this isn't some brand new idea. We've seen this before. Major, high-profile attacks like Print Nightmare, and even the bug tied to the Stuxnet attacks, they've all exploited printing services for years. And we're not talking about some small, minor bug here. No way. These are the kinds of vulnerabilities that give attackers complete, total control to run whatever code they want with the highest possible system privileges. Okay, so if we've known about this stuff for years, what's the deal? Where's the weak spot that everyone seems to have missed? Well, researchers have finally found it, and it's hiding in the very first step of the printing process, that split second when your printer tries to figure out what the heck you just sent it. So this diagram here lays out the modern Windows printing workflow. And here is the absolute key insight. It doesn't matter what you're printing, a PDF, a Word doc, a photo, whatever. It almost always gets converted into this middleman format called XPS. You can kind of think of it as a universal language that all printers understand. And this happens before your file even touches the physical printer hardware.
So the crucial point is this. Every single document gets funneled through this XPS format. Every single one. That means the piece of software that reads, or to use the technical term, parses these files is basically a gatekeeper for the whole system. And what's crazy is that it turns out nobody was really watching that gatekeeper. It was a total blind spot.
So you've got to be asking, why? Why has this been a blind spot for so long? Well, it's because hunting for bugs in this specific little component is like trying to navigate a maze while you're blindfolded. There are two massive challenges here. First off, just creating the test files you need to poke and prod for weaknesses is a complete nightmare. See, an XPS file isn't just a bunch of text. It has these incredibly strict, complex rules about its structure. The best way to think about it is like a super complicated recipe, where every single ingredient and every single step has to be in the perfect order. If you mess up one thing, the whole dish just gets thrown out, rejected.
I mean, just look at the level of detail we're talking about here. If you get the hierarchy wrong or you mess up the sequence, just one tiny mistake and bam, the entire test fails. It gets rejected before it even gets a chance to start looking for the real juicy security bugs.
And the second huge challenge is that the code for the Windows printing system, well, it's not public. It's a black box. Researchers can't just pop the hood and see how all the different parts are wired together. This makes it insanely difficult to figure out how to trigger the specific bits of code they actually want to test. So how in the world do you test a complex system that's a total black box? You can't just grab a tool off the shelf. It won't work. So the researchers had to build their own weapon, and they called it PrintXPSurge. Now, PrintXPSurge is a special kind of tool called a fuzzer. If you're not familiar, fuzzing is basically an automated testing technique. The best analogy I can think of is it's like having a robot that automatically creates and tries thousands and thousands of slightly weird, malformed keys on a lock, just over and over again, to see which one will finally break it open. But PrintXPSurge isn't just about brute force, throwing random stuff at the wall. Not at all. As you can see from this workflow, it uses this really clever four-stage process to systematically and intelligently hunt for vulnerabilities. It's designed to outsmart both of those big challenges we talked about, the file complexity and that black box environment. But it's really the third step in that process, the one called AI-powered format repair, where this whole thing goes from just being clever to being, well, truly groundbreaking. This is the cool part.
So remember that huge problem of creating perfectly formatted test files? How did they solve it? Well, it's pretty simple, actually. Instead of trying to be perfect from the get-go, they built a tool that could learn from its own mistakes. It's almost like teaching a robot how to pick a lock by letting it feel out what works and what doesn't. So whenever the fuzzer made a file with a mistake, the printer driver would, of course, reject it. But it would also spit out some cryptic error message, and this is where the genius part comes in. The researchers took that error message and fed it directly into a large language model, an AI. And that AI could actually understand what the error meant and then automatically fix the broken file, creating a perfectly valid version. This AI-powered feedback loop is the absolute secret sauce of the whole operation. It literally let the fuzzer teach itself all the complex rules of the system just by learning from its own mistakes in real time. And because of this, it could generate thousands and thousands of valid, complex test files at an incredible speed, letting it get way deeper into the code than anyone ever has before. All right, so what happened? What happened when they finally unleashed this incredibly powerful new tool on printer drivers from 10 of the biggest brands in the world? What did PrintXPSurge actually dig up? The results were just staggering. In the drivers from just 10 major printer brands, PrintXPSurge found a whopping 102 bugs. And let me be clear, these were not minor glitches. We're talking critical security issues, things like memory corruption, that an attacker could absolutely exploit. But what's even more alarming, 17 of those were confirmed zero-day vulnerabilities. Now, a zero-day means it was completely unknown to the companies that made the software. No one knew about it, which means no patch existed. These were just wide-open doors. And get this, 13 of those 0 days were in official Microsoft code.
So what's the big takeaway here? This research proves that huge secrets can be hiding in plain sight, even in the most boring, everyday devices we use. But I think what's even more important is that it shows us a new way forward. By combining smart, automated tools with the power of AI, we can actually find these hidden flaws. And it really makes you wonder, right? It's not just about what other devices on your network might be vulnerable. The real question is, what other black box systems out there in the world could be cracked wide open using this exact same approach?